This idea of function invocation, function calling, is really important. It's central to how we're going to use functions to control our code. So I want to work through in a little more careful detail exactly what happens when we call a function and how we get values associated with variables. You'll see on the screen here I've got a little piece of code. I'm defining a function called f. I'm binding x to 3, and then I'm going to call f with the value of x and bind that to z. Let me show you what happens if I actually run this. So on my computer, I've got a version of that file, and I'm going to load it into my shell. And what it prints out, as you can see, is it says in f of x, x is equal to 4. How'd that happen? What's going on here? Because x seems like it's used in a lot of places. So this is going to be an important opportunity to look at how functions are called. As I've already said, the key idea is each formal parameter, in this case I only have one, is going to get bound to the value of the actual parameter when the function is called. And then when I call a function, I'm going to create a new environment, sometimes called a frame or a scope, a new place in which I'm going to bind variables and relative to which I'm going to evaluate the body of the function. Think of that scope as a mapping of names to objects. And in fact, we've been using that idea. When we were just talking to the shell, when we defined x to have a value of, say, of 5, we were creating in the global scope or frame a binding of the name x to the value 5. Now, let's look at this in a little more careful detail. Imagine I now do what I just did on my computer. I evaluate this sequence of expressions. There's that formal parameter. There's the actual parameter I'm going to use. And let's look at what happens. I evaluate that, and in that global frame, I create a set of bindings. First one is evaluating that definition binds the variable name f to something. Oh, but that's important because that something is just a set of code. I haven't run f yet. I haven't tried to do x equals x plus 1 or anything else. I've literally in the machine said associate the name f with a chunk of stuff. Next thing I did was I evaluated x equal 3, and that just creates a binding. We've seen this before. So in the global scope, x has a binding to the value of 3. And now I'm ready to evaluate that last expression, which says give the name z the value of calling f on x. And I'm ready to do that. Now remember, before I can actually do the binding of c, I have to get the value of that expression. So calling f literally creates a new scope, a new frame. It will actually inherit things from the global frame if it needs it, but right now I've got a new environment. The definition of x has a formal variable x, and that's exactly what that corresponds to. And the value associated with it is the value of x that I passed in, which actually came from there. I know it looks a little confusing. I'm deliberately using two different values of x so you can see where the bindings come from. So f evaluated on x says, what is the value of x? I get it from the binding that I just previously. So inside that f scope, x is bound to 3. Now, relative to that scope, I'm going to evaluate the body of f. I want to do the work that f says it's going to do. So let me see what happens there. First expression says, evaluate x plus 1. And I'm actually going to go back for a second. Remember, in the f scope, x has the binding of 3. I add 3 plus 1, that's 4, and I create a new binding for x, but in the f scope, because that's where I'm doing the work. So it changes it here. It does not change the thing that was out in the global frame. That's great. Now, relative to that, I'm going to print out something, and on my computer screen you saw it said, in f of x, x is equal to, the value of x in the f scope, and that's why it printed out 4. And then what it's going to do is it's going to return x. So literally it's going to get the value of x in the f scope, which is 4, and it's going to return it to the person who asked for it. And what was that person? That was down here. We're doing the binding of z. So I've just returned to that binding a value for f of x, which is 4, and that creates the binding for z. If this is a little confusing, watch the same segment again, because this is an important idea. Anytime I do an rephrase that. Anytime I do an invocation of a function, I create a new frame. I bind the formal parameter of that function, or parameters if there's more than one, to the values of the expressions passed in, and relative to that frame, I now evaluate the body of that expression. When I'm done with the body of the function, if there's a return, I'm going to send the value back to whoever called for it and erase or remove that frame because I no longer need it. Okay, with that idea, let's look at a couple of other examples. First, what happens if there's no return statement? Here's my function from before, is even. But rather than returning is the remainder of I divided by 2 equal to 0, I just have the expression. So there's no return here. What happens in this case is that Python returns the value none because I did not give a return. So Python will say in a function call, if you don't have an explicit return, I return the none value. It represents the absence of a value, and unfortunately that would mean in this case I would not get back the answer of true or false. I would simply print out nothing because there's nothing to be returned. Point of this is anytime I want a function to do something, unless it's simply doing something we call a side effect, I always want to have at least one return that's going to give a value back. So remember to keep your returns in. In fact, that gives me a chance to talk about the difference between return and print. You can see the description here, and let's just do it quickly. Return only has a meaning inside a function. It's the only place we can use it, inside a function. I could have more than one return. If I have branches or other conditionals, I might have different places from which I want to return, but only one return will ever be executed inside the function because it's going to throw me outside of the function and return a value. Any code inside the function but after the return statement will never be executed. And of course, a return does have a value associated with it. It's given back to the person who called the function. By comparison, while return has a meaning only inside a function, a print can certainly be used inside a function, but it can also be used outside of a function. We've already seen that. We can also execute many print statements inside a function, and any code inside the function after that print statement can, in fact, be executed. Again, a print has a value associated with it, but it is simply output directly onto the console rather than being returned. So prints are going to be handy to have us pass information back to the user to let them know the status of a computation. Return is the way in which I'm going to get a value back to somebody who asked for it, whether it's me as the user or some other function call. With that in mind, let's look at, in fact, how you might have other function calls. So, not only can parameters have numerical values, they could also have other values, including being a function. So I have three definitions of functions here. The first one, A, takes no parameters. I said this earlier, but I'm going to say it again. Notice it has an open and closed paren. That's important. I have to tell it that there are no parameters there. Function B takes one parameter, in this case called y, and function C also takes one parameter. In this case, it's z. What's interesting about this is how these functions are going to use them, and in a second I'm going to run it, but notice I'm going to call function A with no parameters, so an open-closed paren to tell me there are no parameters. I'm going to call function B. It's going to take in one parameter. In this case, I'm going to give it a number. And function C is going to take in one parameter, but in this case, it's another function. Whoa, that's funky. It's actually okay. I can pass in the name of the function, and that will literally pass the actual function in to that parameter call for function C. Let's see what happens if we try this. So I've got that code loaded up over here. I'm going to pass it into my computer. And notice what it printed out. The first thing is it printed out inside function A. That came from calling this function, and that's the print statement right there. There is no return in function A. And so, in fact, the print takes the value returned by function A, which was none, and it printed it out on my computer. I then take the next call. I pass in 2 to function B. Function B prints inside function B, right there, which is the next thing it did. And then it returns the value passed in, which is the value of y, which is 2. That gets added to 5, which is why on my machine I printed out 7. The print statement printed out 7. And then the last one, again, a little funky. I passed in function A as an argument for z in function C. And what happened? It printed out inside function C, and then it called a return of calling z with no arguments. And what's z? It's function A. Oh, that's nice, because function A then said print out inside function A, which it did. return nothing because there is no return statement. And so this print at the bottom then printed out none. We could step through it more carefully, but you hopefully get the idea. In each case, I'm simply evaluating the body with respect to a frame. And the arguments could in fact be other functions that I can invoke inside of a function call, which I did inside of function C. So, as a consequence, inside of a function, we can both access a variable defined outside as well as a variable defined inside. On the other hand, inside of a function, we can't modify a variable that's defined outside of the scope of that function. And here I have three little examples just to give you a sense of that. What I'm going to do is show you basically what would happen for each one of these function calls. So I've defined f of x to be set x equal to 1, add 1 to x, and then print out the value of x. I've defined g to simply say print x, and then print x plus 1. And I've defined h to have a body that says simply increment x by 1. And I want to think about what do those things actually do. Well, let's look at each of those examples. In each case, I'm going to define x to have the value of 5. I'm going to call the function with that value of x, and then I'm going to print out x. What happens? In the case of f of x as 5 is passed in. I redefine x to be 1 inside of there. And then I add 1 to that value of x, which is 2. And then I print out x. So in fact, f of x is going to print out the value 2. And then this print statement is going to print out the value 5. Why? Because it sees the value of x defined in the global scope, which is where I am. What happens with the case of g? G says, well, first of all, I call g with the value of x, which is 5, which means 5 is going to be used in place of y. And then I say print x. You say, wait a minute. There is no x as a parameter to g. That's fine, because it then says if I can't find it in the frame associated with g, let me look outside. And there is a value, which is 5. So in this case, it's going to print 5. Then it's going to print 6, which is x plus 1. It has no return, so it's not going to do anything else. And then I'm going to print the value of x, which I get from here, the global environment, and it's going to print 5. Finally, I define h of y. I've done that. I've defined x to be 5, and now I call h with the value of y being 5. And what do? I'm going to print out, sorry, not that, rephrase that. I'm going to try and define x to be x plus 1. And let's think about what happens. So just to go back to this, I've already defined x from outside g. That's why I pick up that scope. What happens in the case of h? Oh, I got an unbound variable error because I'm trying to look up the local variable value of x. I'm referencing it before I've assigned it. So in fact, I'm going to complain about this, and I'm not going to succeed. So we can see I can look up values outside the scope, but I can't change the values of those things outside of the scope appropriately. And that's a place where I have to be careful about how I actually use these different procedures. 3 different examples shows you different ways in which we can deduce how we actually pick up the values of the variables. And in each case, as I said, the x comes from the global or main program scope when I print out this value at the bottom down here. Okay. I'm going to show you one more example of scoping. I want to do a quick aside which says when you get to really tricky things, there's a nice place to go look, which is this place on the web called the Python Tutor that helps you sort these pieces out. And the last example before we move on to other topics is to look at something that actually has a function defined inside another function. Wow, that sounds neat. Here I've got a definition for g, and inside of there I've got a definition for h. And if I look at this code, I'm going to actually run it over here. Let's see what happens when I run it, and let's see why it does that appropriate thing. And when I ran it, it prints out the statement inside g of x, x is bound to 4. And I want to see how that comes about. So here we go. When I evaluate, or when I just in fact evaluated inside my machine this description, here's what happened. As I saw before, in the global environment, g was bound to a bunch of code. Where's h? Hasn't happened yet. It's simply sitting in a chunk of code. We have not yet evaluated that body, so nothing has happened yet. X is bound to 3. So when I get to the point shown by the arrow here, this point in the code, I've got G as some code, and I've got X bound to the value of 3. Now I'm ready to do a binding for Z to be a call to G. We saw what happened before. G creates a new scope, and inside of that scope, I'm going to bind the value of X, and that X is coming from the formal parameter for G. The value is coming from the binding for X in the global scope. So X is bound to 3. And then I'm going to evaluate the body of G. And this is cool because that says inside of here, I'm evaluating the definition of H. This is sometimes called an internal or helper function because it belongs only to G. The binding for H right here is to some set of code. Only when I'm inside of G can I use H. It's protected. That's great. Haven't used it yet. I've just got a binding for H. And then what do? I create a binding for X, and notice what happened. I say get the current value of X, which was 3, add 1 to it, and then change the binding for X in the scope of G, because that's where I'm doing the work. So it's changed that binding for X, but not this one over here, which is still 3. And then I do the print statement, which is why it says in G of X, X has got the value 4, because in fact I see this value of X over here. All right, almost done. Now I'm going to call H. H is a function. It's right there. And since I'm invoking it, I create a new scope. And this scope inherits from G, which inherited from the global scope. Inside of H, I bind any formal parameters. There aren't any. What do? I evaluate the body of H. So I bind X to the string ABC. And then, what do I return? Nothing, because I have no return statement. So having done that binding for X, I'm done with the call to H, and there is nothing to return. Having done that, I'm now ready to do the last part of G, which was to return X. And you notice that binding inside of H of X equal to ABC is gone. It's been garbage collected. And so I now simply return the value of X, which I know is defined inside the scope of G, and that gets returned as the value that I associate with Z. Perfect. I'm now set because Z has the binding 4. So there's a more complicated example, but you notice how those rules for scopes very nicely tell me, and more importantly tell Python, exactly how to look up values and how to use those to store new values as I do bindings.